All right, today we're going to unpack a really wild idea called ergodicity economics. It's a concept that pretty much flips our whole understanding of risk on its head, and it explains how a bet that looks like a sure thing can actually be a guaranteed way to lose everything.
So let's just dive right in with a question for you. Imagine I offered you this exact bet. We flip a fair coin. If it's heads, your net worth goes up by 50%. If it's tails, it drops by 40%. What do? I mean, really think about it. Your gut reaction here gets to the heart of a massive, and I mean massive, idea in economics.
And here's the paradox, right? On paper, according to standard economic theory, you should take this bet every single time. But your intuition, that little voice that knows you only get one life to live, is probably screaming something different. That conflict, well, it points to a huge flaw in how we usually think about risk, and the solution is this powerful idea called ergogenicity economics.
Okay, so first up, let's break down why this bet looks so good in the first place. To do that, we have to put on our traditional economist glasses for a minute.
The classic tool they use is something called expected value. Now, the key thing to understand about expected value is that it's an average calculated across a huge group of people, a whole ensemble as they call it, with each person taking the bet just one time. It's like taking a statistical snapshot of 1,000 people playing at the exact same moment.
And when you do the math, look what happens. You've got a 50% chance of a 50% gain and a 50% chance of a 40% loss. You run those numbers and you end up with a positive 5% expected return. So from this ensemble view, the average person in that big crowd of bettors comes out ahead. It looks like an absolutely fantastic deal.
But, and this is the whole point, you are not a statistical average. You aren't spread out across 1,000 different people. You are one person living one life, and you make your choices one after the other, through time. And this brings us right to the core of what ergodicity is all about.
This lays it out perfectly. There are two completely different ways of looking at this. You've got the ensemble average. That's what happens across, say, 1,000 parallel universes where 1,000 versions of you each play the game one time. But then you have the time average. And that's what happens to the one and only you playing that same game 1,000 times in a row, right here, in this universe.
So here's the key term. When that parallel universe average is the same as your single timeline average, the system is called ergodic. But when they're different, which it turns out is true for most of the big financial and life decisions we make, the system is non-ergodic. And that, my friends, changes everything.
So let's put it to the test. Let's forget the parallel universes for a second and just calculate the time average. Let's see what actually happens to your money when you play over time.
Okay, let's run a little simulation. You start with $100. To make it super simple, let's say you play just twice, and you get one of each outcome, one heads, one tails. Because in the real world, the order of events is everything, right? Your next bet is always based on whatever money you have after the last one.
All right, first toss is heads. Boom, your $100 grows by 50% to $150. You're feeling pretty good. But on the next toss, it's tails. You lose 40%, but not of your original 100. You lose 40% of your new total, that $150. Well, 40% of $150 is $60, and you're left with just $90. Wait a second, after one win and one loss, you're actually down 10%.
And this is not a fluke. It's not just bad luck. The math that rules outcomes over time is multiplicative, not additive, like the other one. And the long-term time average shows that with each pair of bets, your wealth is, on average, being multiplied by about 0.95. You are on a track to lose 5% of your wealth over and over again. You are literally heading towards zero.
So as you can probably see, this is way more than just a clever math trick. This difference between the average of the group and your path through time, it has huge, profound implications for economics, finance, and pretty much your entire life. And this idea has had a fascinating journey. It actually started way back in the 1800s in physics for modeling gases of all things. Then it was brought into economics, but this little assumption that the group average is the same as the individual's path, it just kind of snuck in, and nobody really questioned it for decades. Not until a physicist named Ole Peters came along and showed what a massive mistake that was.
Once you start looking at the world through this lens, so many puzzles in economics that seemed totally irrational suddenly click into place. It explains why we buy insurance, even though it's technically a losing bet on average. We're not trying to maximize our average outcome, we're trying to protect our one single path from getting wiped out. It also helps us understand why wealth inequality can get so extreme, and why the #1 undisputed rule of investing is to never, ever risk going to zero.
And look, this is not just some academic theory. This applies directly to the big decisions you face. It completely changes how you should think about an investment strategy that looks amazing on average, or that risky career move with a small chance of a terrible outcome, or a business plan where one bad roll of the dice means it's game over for good.
So the really crucial takeaway here isn't just a new way to do some calculations. It's a fundamental shift in how you see the world you're actually operating in.
Here's the most important thing to get. You don't get to average your outcomes across all the different lives you could have lived. You only get one path. And on that one path, a devastating loss isn't just some data point that gets averaged away. It's a permanent change in your story, one you might never recover from.
The thinker Nassim Nicholas Taleb just nailed this perfectly. He said, sequence matters and ruin problems don't allow for cost-benefit analysis. What he means is you can't just average in the possibility of going broke. The risk of ruin isn't just another variable in the equation. It is a hard stop. It's a constraint that changes the entire game.
And that really leaves us with the big question, the one to take with you. When you're making your choices, are you thinking like a statistician who's analyzing a big crowd, or are you thinking like a survivor, carefully navigating your one unrepeatable journey? Because understanding that difference, that might be the single most important bet you ever make.